Good evening. Selamat petang diucapkan kepada semua pelajar tingkatan 5, sesi 2021. Jadi hari ini saya akan meluangkan masa untuk membuat ulang kaji sedikit subtopik yang kita kata topik kedua, subtopik elasticity. Alright? Okay, elasticity yang berkaitan dengan spring. Sebelum kita mulakan, kita tengok definisi elasticity. Okay, what is elasticity? So when we say something elastic means what? It is like the rubber band here. Alright, when I pull, alright, it becomes longer. When I let go, alright, it will shorten. Clear? So this is what we call elastic. Because when I apply force, it becomes longer. When I remove the force, it becomes shorter again. Clear? So the ability of material to return to its original shape. Okay, kebolehan suatu bahan untuk pulang ataupun balik ke bentuk yang asal. Okay, when the force is removed. Bila daya dikenakan itu, okay, kita keluarkan. Alright. Jadi sebelum itu kita kena tahu apa maksudnya elastik. Alright. Bukan semua benda elastik. Kita tahu. Okay. We know this rubber band. It is elastic because you can easily extend. Alright. So maksudnya kalau kata we say that rubber band is elastic, meaning it is soft. Clear? Alright, it is soft. The same go to this sponge. This sponge, okay, we can compress it. Okay, we can compress. We can compress easily. So it also means elastic. Alright? So most of the elastic material is soft. Alright? Most elastic material is soft. But okay, not all soft material is elastic. Okay, sponge, for example, it is elastic and also soft. Clear? Rubber band, this is elastic and it is also soft. All right. Okay, my skin is also elastic. All right, it is also soft. But they are objects which are soft but not necessarily elastic. Okay, for example, okay, plasticine. We all know plasticine is soft, but it's not elastic. Because if I give you a plasticine ball, you compress it, it becomes flat. When you let go, it will not become plastic ball again. Okay? Alright? It will not become plasticine ball again. Clear? So that is the reason of, okay, it is soft, but not necessarily elastic. But most elastic object is soft. That one you understand first. Okay? Point number 2. When we say object is elastic, it actually means soft. But in physics, we don't use the word soft. We will use the word less stiff. Right? Less stiff. Okay? But for your understanding, it will be good for you to think of the word soft. Okay? Soft. Alright? Boleh? Soft. Okay? The opposite, when I say that the material is not elastic. Alright? When the material is not elastic or elasticity is low, then it means the opposite. Not elastic means it is hard or, alright, very stiff. Okay, high stiffness. Okay, alright, and we are going to use the word hard. Alright, in bahasa kita panggil sebagai keras ataupun kuat. Okay, then we're going to look at the factor that affect the stiffness. Alright, so normally it refers to spring, okay, or rubber band. Number 1 is the length. Okay, the length. Okay, so we know, okay, just like rubber band. If I have a short rubber band, all right, if I have a short rubber band, I can extend to certain length only. But if I have a longer rubber band, all right, if I go and tie the rubber band together and I have a longer one, you know that I can extend even longer. Agree? So the longer the spring, the softer it is. Okay, all right, huh? When it is long, it is soft. When it is short, it becomes hard. Okay, so I give you an example of this spring. This spring is short. This part is very hard. I want to extend it. It's not easy, you know. I need to apply a very big force. Then only I can extend. Clear? All right. So in other words, I'm going to write down here the relationship. All right. When the length is short, all right, then it is actually stiff. All right. When it is short, it's actually stiff. So I write the word stiff. High stiffness. Okay. Right. High stiffness. Okay. All right. The second one is going to be the diameter. All right. Diameter. So diameter refers to the diameter of the spring. We have small diameter like this, All right? We have big diameter like this. All right? This is bigger diameter. I'm sure you can see this. Smaller diameter, I have it here too. All right? This is man-made spring. So understood, if it is small diameter like this, okay, diameter is small, understood, it's actually harder for me to pull. All right? Okay? So diameter small, okay, diameter kecil, dia lebih keras. But if I have a bigger diameter, you can see this, all right? You can see, we call it, okay, you can see the coil is bigger, all right? You can see the coil is bigger, all right? So it's easy for me to extend because it is softer. You see, I can easily extend it. Boleh? All right? So in other words, when diameter is big, all right? When diameter is big, it becomes soft. Then terbalik, when diameter, D for diameter, okay? When D means diameter, when the diameter is low, then it becomes stiff. Okay? All right? It becomes stiff. That's why I always tell students, okay? Not everything which is long is good. Okay? All right? And not every time it is big, it is good. All right? It's opposite. All right? And it is short and small. Short because L is low, short and small because diameter is smaller. All right? Short and smaller, then it become what? Stiffer. It become harder. Boleh? All right? This one you have to know. Okay? Third one is going to be diameter of the wire. It's still diameter, but this is diameter of the wire. Okay? Wire meaning I need to draw here. So I'm going to give you two springs. All right? Okay? We are going to have the first spring like this. All right? And we're going to have another spring also the same. But the second spring, I'm going to have the wire bigger diameter. Meaning I am going to draw another one more time. All right? To make the wire become thicker. Thicker. You see, lebih tebal lagi. Lebih tebal. Ataupun saya lukis lagi satu kali. Lebih tebal. So understood. Okay? Logic will tell you. All right? If the wire is thicker, then it is stiffer. All right? So I'm going to put down here. This is diameter of wire. I put a DW. Okay? Diameter of the wire bigger, then it will give you a higher stiffness. Okay? Higher stiffness. Boleh? All right? And the last one is actually the material. All right? Material. Different material will give you different stiffness. Understood? All right? This spring is very stiff because it's made of stainless steel. All right? It's made of stainless steel. But if I were to make use of, let's say, iron to make this spring, it becomes softer. All right? Or if I use copper, it will be even softer. Clear? This is something that you need to know. Then we're going to go ahead to what is known as Hooke's law. All right? Very simple. Okay? Hooke's law tells us that the force applied is directly proportional. All right? The force applied is directly proportional to extension. All right? Okay, this one normally is an N. All right? This one normally we use centimeter. We can also use meter. It's going to be a straight line that goes through origin. All right? Now, whether it's a higher gradient or lower gradient, it doesn't matter. As long as it is a straight line go through origin, then we will say that the force is directly proportional to extension. All right? It's going to be written like this. Force directly proportional to extension. All right? And in math, when we take away this direct proportional, you have a K, which is constant. So this K is called force constant. All right? Or also, spring constant. Clear? Sometimes they will ask you to look for the K. All right? Example, okay? All right? I'll show you how to get a K. We know that KE become F. So in order to get a K, it will be, okay, F, okay, over E, okay? It will become F over E. All right? That is the formula that you are going to have, F over E. This is what we call spring constant. Okay? For all you know, every time we use K, it always refer to constant. Boleh? All right. Then we're going to look at what to apply. If I were to give you, let's say, a system of spring. Okay? Let's say I'm going to give you a simple one. All right? Okay? Original drawing of the spring. Okay? Let's say, I'm going to give you, let's say, one spring system whereby the original length is going to be 10 cm. All right? 10 cm. All right? 10 cm. Then I'm going to apply a force of, let's say, 2 Newton. 2 Newton. Right? When I apply 2 Newton, understood, it become longer a bit. All right? Okay? It should become longer because the force will extend the spring. Boleh? all right? Extend the spring. So I'm going to put a 2 Newton here. Okay, boleh ha? Right? So we have a system here whereby, all right, okay, how much force is applied, it will give you extension. All right, and then for this system, you have to give the relationship. Berapa daya dikenakan menghasilkan berapa pemanjangan. F for daya, okay? F for force, daya. E, extension, pemanjangan. So I'm going to put the value there. Let's say this is going to be a 12, all right? So it's very, very clear, all right? From 10 to 12, extension will be 2 cm. And you apply 2 Newton, okay? All right, so it's a very straightforward. 2 Newton, give you extension, 2 cm. So in exam, how do they treat you? All right, I will draw here. All right, I will draw here. They will purposely give you, all right, a system, right? They will look like this, all right? A system that will look like this. Consists of 2 sets, right? It consists of 2 sets, okay? And we arrange it in a series. This is arrangement of series. All right? Series dalam bahasa, all right? It's going to be called, okay? Series, okay? All right? And let's say I'm gonna put, okay, 4 Newton. I hang 4 Newton. So what type of question they will ask? They will ask you, number 1, find extension. Number 2, find the total length. Okay? Boleh ha? Very simple. So we're going to use this relationship because this spring and this spring, they are identical spring. All right? We use similar spring. We only arrange in series. Okay? So 2 Newton give us 2 cm extension. 4 Newton, understood. Okay? By ratio, it will give us 4 centimeter. So in other words, this 4 Newton will extend, okay? Will extend spring A, okay, by 4 cm. It also extends spring B, also by 4 cm. So in other words, spring A extended by 4 cm, spring B also extended by 4 cm, then we will have a total, okay, 8 centimeter extension. All right? And they ask to find the total length, very simple. All right? This arrangement consists of 2 layers, 2 tingkat spring. Okay? Satu tingkat panjang asal 10 cm. So panjang asal we will put LO. All right? LO, panjang asal. LO. Clear? All right? So we know we have 2. Okay? We have 2. Right? So we're going to put a 2 LO. All right? We're going to put a 2 LO. All right? 2 LO. All right? Plus extension. So very simple. Then you're going to get a 2 times with a 10. All right? Plus with a 8. So you're going to have a total 28 centimeter. Boleh? All right? Okay? This is not the only way to solve the question. Huh? All right? This is not the only way. You can use this method to get it. All right? You can use this method. All right? Macam mana kita buat cara ini? Okay. First, we need to find the K for the original system. All right? I'll show you. Huh? All right? We find the K. All right? From here, you get the K for the original spring. So the original K is actually going to be, you're going to use this formula. All right? So, kita masukkan nilai ke dalam 4 Newton. All right? 4 Newton at the top over, okay, not 4, 2 do. No need to put 4. All right? You put smaller number is even easier. 2 Newton, it will give you extension 2 cm. Betul? Then your value for K is 1 Newton per cm. Boleh? This is the original K. And now we have this series. And you know, when it is series, ring series, your spring become longer. All right? Longer. When it become longer, you hear it's written when it is shorter, it becomes harder. All right? Shorter spring is stiffer or harder. So longer spring, it becomes softer. So when it becomes softer, your new K, all right, it becomes softer. I put the word softer here. Soft. All right? Soft. Okay? Soft. So when it is soft, your K will have a smaller value. Okay? Your K will have a smaller value. So I'm going to do the calculation over here. All right? I'm going to do the calculation over here. All right? Here. Okay? Probably here. Okay? I find a new K. Huh? I find a new K. New K, which is going to be, all right, the same formula, F over E. All right? So I will put in, no, I don't use this formula first. Right? The new K, all right, because it is softer, Softer meaning lower stiffness, okay? All right, lower stiffness. All right, so the value of the K becomes smaller. How to get value of the K become smaller? We will get the original K divided by 2. Original K divided by 2. Why divided by 2? 2 spring in series. Clear? Alright, kita akan ambil nilai ini. Alright, I draw a line here first, okay, to separate them. So we will get this value here, 1 here, alright, okay, 1 here divided by 2. Okay? Then your new K is going to be a half. Then we will use this for calculation. Alright, we will use this formula for calculation. Alright, okay, we will do it here. F equals to K, alright, E, okay? Right? Then we put 4 Newton here. Alright? So masukkan 1 over 2. Alright? 1 over 2 over here. And the E. So when you cross multiply, you know that the E will still become 8 cm. Alright? It will be the same as what we have here. What? This is kaidah using what? Alright? The method using force constant or spring constant. Boleh, ha? Alright? So what does it mean? K actually represent what? Kekerasan. Alright, kekerasan. K meaning kekerasan. Kalau nilai K lebih besar, then dia punya nombor lebih tinggi. Clear? Alright, dia punya nombor lebih tinggi lagi. Okay, ha? Right? So I'm going to give you another spring which is going to be parallel. Okay? Alright, another spring system which is going to be parallel. Alright, I'm going to put like this. Okay, this drawing. Okay? And another drawing. Alright? Another spring here. Okay? Okay, another spring here. Okay, then I'm going to apply 4 Newton. Okay? Boleh? Right, 4 Newton. So according to this one, 2 Newton gives 2 cm extension. 4 Newton, alright, it will give you, okay, 4 Newton will give you 4 cm extension. Betul? So I know that it will give me 4 cm extension here. Alright? But it is supported by 2 spring. Alright, supported by 2 spring, we will divide by 2. So your extension will be a 2 cm. Boleh? So I will get my answer there. Therefore, extension become a 2 cm. What about the total length? Total length, we know this is 1 layer. Alright, this spring consists of 1 layer. Alright, and because it consists of 1 layer, your LO is only 1. Okay, 1 LO. LO plus E. Okay? So 1 LO is going to be a 10, original spring, 10 cm, tambah 2, then you are going to have a 12 centimeter. Boleh? We can use this method to do, spring constant. Alright? And we know that this arrangement is actually, alright, in parallel arrangement. So parallel arrangement will actually make your spring become stiffer. It become harder. Alright? It become harder, hard. Okay? It become hard. Alright, it become hard. Then I will use the word here, higher stiffness. Alright, I'll put the word here, higher stiffness. Okay, so I will put it here, higher stiffness. Okay, higher stiffness. It's opposite of this one, lower stiffness. This is lower stiffness because it's series. Alright, parallel, higher stiffness. Boleh? Right, so to get the answer, I need to find your new K for this system. Alright, ini adalah sistem baru. So saya cari nilai K yang baru. Alright, and kita tahu bahawa when you arrange in parallel, it becomes stiffer. That means your K must be bigger. Alright, your K must be bigger, then you must multiply. You will get the original K, multiply by how many springs here? Alright, multiply by 2 springs. So in other words, I will have a 2 multiply with the original K. Just now, we will take the original K divided by 2 because it's series, which produce softer system. Now, parallel, it produce harder or higher stiffness system. We multiply. So you take a 2, multiply with the value here, which is 1, then you get a 2 here. So this is a new K. So with this new K, you're going to substitute, okay? We're going to substitute, all right, into this particular formula, all right, again, all right, this formula again, all right? Okay, I'm going to draw a line here, right? We're going to substitute into this formula, all right? Get, all right, your answer for extension, all right? Okay, get your answer for extension. So I will put in the number there, all right? The force is 4 Newton, all right? Nilai K baru, the new K is a 2, So understood your extension, you will still get the same answer like just now, which is going to be a 2 cm. Boleh? Jadi ini jawapan dan ini jawapan adalah sama. Boleh? I think it's pretty clear. You'll be able to see everything here. Alright? Jadi, dalam peperiksaan, kalau soalan ditanya dalam objektif, you will use method ratio. Alright? Okay, perkadaran. Okay, apa yang ditunjukkan tadi. Gunakan perkadaran. Buat macam ini. Alright? 4 Newton, 4 cm. Then 4 cm, 4 cm, total 8 cm. Alright? Tetapi kalau soalan, alright? Kalau soalan or question ask structure, they need you to do calculation. Then it will be good for you to show, alright, force constant, alright, of spring constant. Get the value first, alright. And if it is series, what you do is you are going to take the original K, divide by the number of spring. 2 spring divided by 2. Then you get new value of the spring constant. You're going to substitute into this one and find your answer for your extension, which is going to be the same as what you get here. Boleh? So, kalau dia adalah selari or parallel arrangement, it will make your system become stiffer. So, stiffer, your K, you will multiply with, alright? You will multiply the original K with the number of spring. You have 2 spring here, then multiply by 2. Clear? You have 2 spring, multiply by 2, then you will get a new K. Alright, put into the formula again, you get an extension. Boleh? And the final one before we stop, alright, which I need to make you understand better is going to be this, alright? Okay, I'm going to erase this. I don't need this anymore. Alright, I don't need this anymore. You know the definition of elasticity. I'm going to show you 2 spring. Alright, I'm going to show you 2 spring. Okay, one is 2 graph. One is graph A, the other one is graph B. Alright, okay, one is graph A like this, the other one is graph B here. Alright, I put in dotted line, okay, graph B. Okay, this is graph B, okay, B. Alright, and I will use similar number, I will use similar force, 10 Newton here. Alright, but the extension here is going to be a 2 cm. Alright, but extension for spring B, this is spring B, is going to be for 5 cm. I want you to find out which spring is stiffer. Alright? How to find which spring is stiffer? Very simple. You find the, alright, you find the spring constant. Clear? So I'm going to show here. Alright, for spring A. Alright, for spring A, we know that the formula for spring constant is going to be, alright, it's going to be F over E. Betul? Alright, so we will take 10 Newton over 2 cm. Alright, so my spring constant is going to be a 10 Newton over 2 cm. What I get is going to be 5 Newton per cm. Boleh? Alright, but for spring B, alright, so K for spring B equivalent to also force over E. So I put in the number which is going to be still 10 Newton divided by 5. Alright, 5 cm. So you're going to get a what? You're going to get a value which is going to be a 2 Newton per cm. Alright? So you need to know what is the meaning of this. What is the meaning? Alright? Okay, spring A, this one tells you what? You need 5 Newton to extend the spring for 1 cm. But spring B, you need 2 Newton only to extend the spring by 1 cm. So in other words, spring A is stiffer. Why? You need bigger force. Alright? Spring A lebih keras atau lebih kuat. Alright, so lain kali tengok nilai K. Kalau nilai K adalah lebih besar nilai K, then dia adalah spring yang lebih keras. Or we use the word higher stiffness. So that's why I always tell my student to remember. I always tell my student to remember. Alright, remember what? K means kekerasan. Clear? Alright, K means kekerasan. Okay, 5 Newton give you extension 1 cm. Alright, so when the number is bigger, alright, when the number is bigger, it become stiffer. Boleh? Alright, stiffer ataupun dalam bahasa, we will use the word lebih what? Lebih keras. Okay, lebih keras. Okay, ataupun lebih kuat. Okay, lebih keras ataupun lebih kuat. Boleh? Alright, so if the K carry a smaller number, dia adalah kurang kuat ataupun kurang keras. Less stiff. Less stiff meaning lembut. Meaning elastic. Boleh? So next time, you look at your value of the K. Or another faster way, look at the gradient. If the gradient higher, then it's stiffer. That's why your A will have a bigger number. All right, spring A, all right, value for the K will have a bigger number. That means stiffer. But spring B, all right, where the gradient is lower. All right, spring B has a lower gradient, that means nilai K lebih kecil. Kalau nilai K lebih kecil, that means it is kurang keras or less stiff. Okay, so with that we will come to the end of today's session. I hope you understand, all right, the application of what we call Hooke's law. All right, this graph is actually telling you, all right, the formula or the law known as Hooke's law. All right, they tell you force is directly proportional to extension of the spring. With that, we will come to the end of the special session, all right, that we specially bring to you, all right, to make you understand better the chapter, the subchapter of Hooke's law, okay, which is talking about spring. So you need to do a lot of calculation, all right, in many different kind of arrangement, all right. If or maybe I show you one formula, one question, extra question, okay, so that you can apply, all right, so that you can apply and see how we call it interesting the question can be, all right. Okay, before we come to the end, one more, all right, I'm going to give you a simple one. Not necessarily simple because some people may find it very hard to apply the concept. All right. So I have this arranged, okay, to two springs like this. All right. Okay, and we have probably another one. All right, which I will arrange, okay, to three springs. All right, three springs. So I give you only one tough example, huh? All right, end up with 6 Newton. So as usual, soalan dia, all right, what is the extension? Number 1. Number 2, what is the total length? All right, and then we'll come to the end of our session today. All right, so we use back the team system, huh? Kalau soalan melibatkan banyak spring, mereka biasa akan tanya dalam bahagian objektif. All right, only objective. So you should not need to show all the work. Okay, you're going to use direct. Okay, we call it a ratio method. Okay, so as usual, 2 Newton give us 2 cm, 4 Newton, 4 cm. So understood. 6 Newton will give you extension 6 cm. All right, so it will extend, okay, this layer of spring, okay, by 6 cm. All right, every time you got 6 Newton, you will extend the spring and give you extension 6 cm. All right, so 6 cm for this layer, and another 6 cm for this layer of spring. All right, and another 6 cm for this layer of spring. Boleh? All right, so we know this layer, we got 3 springs supporting, all right, supporting this 6 Newton. So extension divided by 3. All right, divided by 3. Remember just now we divide by 2, remember? Remember divide by 2 because of 2 springs here in parallel. Now we have 3 springs in parallel, divided by 3. All right, divided by 3, then we have a 2 cm extension. All right, and here supported by 2 springs, then divided by 2. Divided by 2, then we're going to have 3 cm. All right, and this one understood. Okay, supported by 1. All right, whether you divide or not, it doesn't matter. You still get back 6. So total extension 6 plus 3 plus 2. All right, 6 plus 3 plus 2. Okay, become 11 cm. Boleh? And what is the total length? Then we know we got 1 layer, 2 layer, the 3rd layer, 3 layer. Okay, 3 layer of LO plus with extension. All right, so you're going to put in the value. Each layer will be a 10 cm plus extension 11. So you know that you're going to have 30 plus 11 will be a 43 centimeter. That is the value of your original length. Clear? Sometimes they will label here as a Y. Okay, all right. They label here as a Y. All right. So what you do is instead of putting LT, you're going to put value Y, which is used to represent LT because it's talking about the total length. All right. With that, we come to the end of this special session, specially brought to you by Sri Sajana, to make sure that you are going to, study in a more meaningful, all right, and easy way to catch the idea and apply all the calculation, right? So till we see again the next session. See you. Bye.